This video is to explain how to do the proof of the identities on page 464, number 24. So identities can be used to solve equations like we've been doing in class, but you can also use them to prove other identities. And an identity is an equation that is always true regardless of the value of your variable. So in this case, we have a statement here and they're asking us to establish or to prove that identity. They're trying to ask us to show that this will always be true. And so you're going to approach this in a similar way to the way that you did proofs in geometry, where you're going to make a statement and give a reason for your statement. And the reasons that you can draw from are these different identities. Some of your reasons might also just be something such as simplify, but you need to give a reason each time you make one step as you go from one step logically to the next. So you're going to start with the left-hand side of the equation. And again, we don't know that this is true. We're trying to show that it is true. So I'm going to start with the left side and I'm going to logically progress to show that it's equal to the right side. So that's my first step. My first step is given. That's what I'm going to start with. And then I'm going to try and change it. Ultimately, I want it to try and look like the right-hand side. So I'm going to think about my different identities that I have to choose from here. And I'm going to choose to change my cotangent into, I'm going to use the quotient identities to begin with. So I'm going to rewrite sine. And then I'm going to change cotangent into cosine over sine. And this is a strategy that often works well, is to change everything into sines and cosines, because then there's a number of things that might end up canceling out. And then I can change my tangent. I'm going to use my other quotient identity and I'm going to change that into sine over cosine. So all I'm doing is I'm just rewriting the same expression, but I'm writing it in a slightly different way. My reason that I know that these two expressions are equivalent to each other is because of the quotient identity. And now I'm going to try and simplify that. So because I have two fractions here and they don't have the same denominator, I'm going to try and rewrite them with a common denominator. And so if I multiply my first expression by cosine over sine and my second one by sine over sine, you'll notice that here now I have a common denominator, sine, cosine. And so again, I'm just going to rewrite my sine theta. Nothing's really going on with that as the moment. And my common denominator is going to be sine theta, cosine theta. This is in the opposite order, but since it's multiplied, it doesn't matter. And then I'm going to have cosine theta times cosine theta is going to be cosine squared theta, plus sine theta times sine theta is sine squared theta. And I didn't use an identity there. All I did was I simplified. So I'm going to just write that that's what I did. And now I'm going to see if I can use another identity. If I look at my identities, I have this Pythagorean identity right there that sine squared plus cosine squared is equal to 1. And cosine squared plus sine squared is also equal to 1. The order that you write those two things, since they're added, doesn't matter. And so I'm going to rewrite this exactly how it was, but I'm going to replace my cosine squared plus sine squared with a 1. And the reason why I can do that is because of my Pythagorean identity. So that's going to be my reason. And now I can try and simplify some more. Those two signs can cancel. And I'm going to be left with 1 over cosine. My reason for that, again, all I did was simplify. And now I'm going to say 1 over cosine. Well, I know that 1 over cosine, if I look at my reciprocal identities, that is equivalent to secant theta. And to go from this step to the next one, I use my reciprocal identity. And the good news is that now I have exactly what I wanted on the right-hand side. And so I have established that the left side of this equation will always be equal to the right side of my equation. This is a great example because it uses the three identities that we learned today, the reciprocal identities, the quotient identities, as well as the Pythagorean identities. As you work through different proofs, you're going to continue using these identities in different ways, and then we're also going to learn about the double angle identities, sum and difference, and power reducing identities.